Oh, this unit here has been a real pain in my ass. It keeps tripping out like randomly, and I just can't get to the bottom of it. I mean, because I can't duplicate it. It's like it runs great and then trips out, runs great, then trips out. So I'm going to see if I can put a logger on it, but to do that, I need to know when it's tripping out. So I gotta see, is there some kind of alarm output down in here? And if not, I'll find another way to do it. I have to get creative, but see, it's in alarm right now. And I've got these dry contacts down here that currently have 12 volts on each of them. Now, I'm going to reset this unit, which you can do via this button right here. That's true of the newer models as well. Alright, let's see if we still got our 12 volts or if that was I don't know what the deal is. Yeah, still got 12 volts on both of those. I mean, it's saying dry, like, you know, dry contacts, but I'm not really sure what they're good for. All right, let me see if we can find a way to make this thing reveal that it's in error. I'm getting into something pretty interesting today, but first, a little TLC is in order. So this right here is a light sensor, and something I made a long time ago, but let me clean up these terminals, and I'm gonna do that with some 5% HCl. Vinegar is my acid of choice, but I do have a video on how I came up with that in a pinch, so I'm going to be using that. Whew, that's a lot of corrosion. Watch how good this is right here on, just eats it right off. So let me get that all cleaned up and then we'll go from there. This right here is my terminal protectant of choice. You know, silicone grease is what is normally recommended, and you know, it's not a bad idea, but I have had cases where silicone grease is just too viscous. It's just too thick, and what happens is it actually gets on the contacts and will prevent connections. I have seen that several times in my career. I've been using this for years in all kinds of connectors. I've never seen it cause problems with plastic. It just does great on corrosion. It's a great cleaner. That's more just the shine from the oil, but this is a great cleaner for any kind of grease or any of those things that you might need to clean up. It also just has a decent smell. You know, this is the only lubricant that I'll use on like foot traps. This little device is pretty straightforward. All it's doing is acting like a analog switch. So when there's no light available, it doesn't pass much voltage through. And then if I let it see light, there's full voltage. Now the response time is lagging a little bit, and some kind of bleed down resistor might fix that. What this is, I don't know. You're just gonna have to Google it. It's an LED. It's basically an LED, but it's hypersensitive to light, and it may have something or another built into it as well. But And I forget, I salvaged this out of some piece of electronics, and I just don't remember anything about it. I've had this thing for years and years. But what it's really good for is picking up signals of light, obviously. But what I mean specifically by that is if you put it on a scope or a graphing meter, it's gonna count the number of flashes. All right, I've got my light sensor taped on the LED screen. I've got it like a little pocket in there, so let's create a code and see if this voltage goes high, because it should turn on there. So an error just turned on, right? So that LED screen lit up, and now I've got my full voltage. So I can log this now, which is awesome. I'll plug it back in. This was just, I think the high pressure sensor, high pressure transducer there. Plug that back in, hit reset. There we go. So now I know exactly when it's tripping out, because I couldn't find anything like alarm outputs on this board. You know, this is such an old generation, I don't even think I can find documentation that discusses it either. So you saw that go high again, and that's because this LED lights up and displays, you know, various types of information as it's booting up, and then it goes out if everything's normal. Let me show you the software setup, and then we'll go over the hardware setup. So I'm going to be taking current in DC volts. Then I'm going to be looking at these temperatures, temperature of the cabinet, the heat sink, and the discharge temperature. And then I'm going to be monitoring, of course, whether or not it's an error. By the way, this is a logger that I showed in another video. I think in that video I said it was an 8-channel logger, but it's actually a 10-channel. And you can set it up to monitor a bunch of stuff, and it takes points according to like the sample rate that you set, and then you can retrieve the data and look at everything in graph form. I'm currently logging all of the stuff that we talked about. That's the LED going high. So that's the LED cutting on and off as it's doing its boot up routine. And this is what we're going to be looking for to try to see when this thing is going to go into alarm. Everything else is pretty straightforward. Discharge, cabinet temp, heat sink temp, and current down there on this probe. This is a probe that I've used for years. Not this one, but this model. And what it does, it's going to output 100 millivolts per amp. Now there's a couple different settings, like if you're going to go up to 60 amps, probably if you go up here you can read actually beyond 60, even though it's rated at 60. This zeroes it out. There's a few other caveats to using something like this, but that's the gist of it. So those are all our channels. And oops, that's not good. One are hanging by the leads, and it bent that one. I had to rig something up because I don't have my banana adapters with me, so I'm dealing with an issue where I can't connect into that up here with a normal lead, because this is already a male, or I guess I should say female. All right, we'll get her booted up and we'll look at the current and different things, and then go from there. It's blazing hot today, so the temps are already up pretty high. All right, here we go. So because it's AC current, it's going to be in an AC sine wave, and you're going to notice that it's jumping up, and every now and then we're getting a sample that shows like 20 amps, but that that's going to be a peak to peak 20 amps, which is not what a meter is going to read. Your meter's reading the true RMS average of this right here. Now, as far as what's going on here, it just has to do with sample rate, and the inverter just changed speeds, and the sample rate just happened to work out so that it was drawing on a line. Now it changed again, and that's why you're getting this kind of choppy stuff, but we don't care about what this looks like, more as in, you know, do any of these peaks like shoot off the chart. If I see any at like 5 or something, that's going to be a problem. Then we've got our cabinet temp, which I've speculated that these units get too hot internally. It's just a bad design, real bad design. And then here's our heat sink, and I think these get up to like about 130 normally. Of course, discharge, that's normal on that. And then our LED is off. So we're gonna let it run, see what we get. All right, let's take a look at this data here. So the first thing I want to do is cut off the current, and we can see that the LED came on at these specific times. Now they're very, very evenly spaced, you'll notice, and so that is peculiar. But if we look over here, I'll get to that in a minute. Let me open up that. We can see that the oil return is every 6 hours, and it's 3 minutes for running step. Now, I don't know what that means exactly. Start run. Because what I'm seeing is that these times are occurring, 6 hours apart, right? And in normal cases, or what looks normal to me, the oil return is on for about 7.6 minutes. And you know, at first I thought that this unit might be having issues every time the LED is on, but that's not the case. It turns the LED on to indicate different modes. I've noticed that. I just forgot about it. But what is going on, what's interesting here, is that it says oil return process ends if compressor protection control starts. So if we go back, we can see that there were a couple cases where the oil return mode went to run and then it just aborted, and there's a successful one. There it tried, and then locked out. Okay, so let's go back now to this screen. Actually, so it is possible to like take one of these traces, and this really is a nice logger here. Let's see, you can kind of like you know, you can make the scale adjusted so it's easier to see what's going on, and you can see like dips where the compressor cuts off, which is pretty cool. But just to keep this video from being too long, let's just look in, let's look in this area right here. So it looks like we had some events like right here where it tried and then had to abort, tried again, and then had to abort, and then it tried again and was successful. In this case, it did the same thing and eventually aborted and just locked out. But as I'm getting like a cursor here, you can see these numbers change. You know, originally I'd said the heat sink temps are around 135, and that's just when I measure them out in the open air. But, you know, going down the entire length of the entire trace, I'm just not seeing any significant patterns. I can go ahead and like open these up a bit so you can see what's going on here. And all of that's to be expected, right? You're going to have those kind of dips and things as the compressor is turning off, because if I put back on the current, current's always messy. We can see that, like in this case, here's the compressor running, and then when that LED comes on, it's shutting off for a while, running, shutting off, and then it locked out. Well, if we go back to, let's find another one. Let's say, let's do a successful one here real quick. I like that. So in this case, you can see that that compressor cuts off for a bit, and then it starts to run again, and then it cuts off and then runs again. And I believe, you know, these manuals are always a bit sketchy, but yeah, there is some stuff going on here where the compressor is kind of changing, you know, its running conditions. But I'm seeing this consistently across all oil returns that look normal. And what I'm not seeing is that same pattern when I start to look at areas that look problematic, like this one in here. And you know, see, there's, okay, so there's a successful one, but then we go this way and there's a failure right there. At least as best I can tell. So the one that we're probably the most interested in is going to be right in here. Okay. But as I'm going through here, I'm not seeing any kind of out of whack temperatures or anything like that. But we do have it narrowed down to it happening during an oil return. Is what, now, was that just happenstance? I don't know. But I don't think so. So let me show you something else. If we just look here, like at the overall pattern. So we had this, I'm calling, you know, normal. And by the way, these drops, I can't say for sure what these drops are. You know, it's really hard to say there. However, you know, the way that I've scaled this, let's just do something else here. The way that I've scaled this sometimes makes it look a bit worse than it really is. Okay, so between these 2 points, I have like 17 degrees. So even though it looks like a really wild shift, I'm just not sure that there's anything to really be derived from that. I mean, who knows what the unit's actually doing. I mean, it could be ramping up and down frequency and doing all kinds of weird crap. And if I get desperate, I might you know, you can chase stuff like that, but you can also waste a lot of time trying to, you know, to overanalyze this kind of stuff, you know, because we're seeing consistent dips across everything. But here's the main pattern that I'm interested in: oil return. Then you get another oil return, and we have that weird pattern of the compressor, and I'm judging this by the current not going through the normal cycle that I'm seeing on these. And then it happens again, and then it happens again, and then a lockout. So yep, I mean, this is something that I'm going to have to keep digging into, and it's kind of something that I'm doing on the side, sort of, not as side work, but it's not a huge priority right now, because it's like it locks out, but then it will reset itself just from the stats alone. So it's been pretty easy to deal with, but very bizarre problem, and I wish that I had a better answer for what's going on. And you know, I might be able to get that at some point, but for now I just don't have enough evidence to suggest anything definitive. And as far as like current and stuff, this is not a perfect trace because my sample size is not set up for that, but just the overall pattern looks fairly normal. I'm not seeing any kind of like wild, out of control current that's causing this. I mean, there's really no kind of weird temperatures. Any of this kind of stuff is from where the compressor cuts off. So I think, you know, I'm gonna have to keep, I might try logging some other stuff and just really looking into how the oil return might be related to this code. But it is quite bizarre. And when I was just looking at the maxes for the three temperatures we have, I found that this value right here, right in here for these temperatures is nowhere near the max that they have been, you know, like let's go here, whoops, boop, and then get that one. So yeah, you know, at one point this got up close to 200, and yes, we are getting a high there with the discharge, but it's still, I mean, I'm looking for something that is gonna definitively set a code, and I'm just not seeing it. Let's look at one more thing. All right, two more things actually. First of all, that this code that it's been tripping out on is a starting failure, and it's related to overcurrent, which I'm not seeing any evidence of whatsoever. Yeah, and then this right here, oops, let's get in here and take a closer look at this whole event right here. Yeah, I'm not seeing any evidence for anything weird going on. Looks like it took a bit to ramp down once that, or I wonder if this was the start of the oil return and then that LED cut off for a while and then through the 27 code. But yeah, that's weird. I mean, there's a lot of stuff you can check over here, like the reactors and all that kind of crap. I mean, I might get into checking low power, but one thing that you have to keep in mind is when this thing locked out, it was at like 5 o'clock in the morning. So, you know, the unit's not under a lot of load for that. And it doesn't seem like it's consistent as far as like time of day or anything. Yeah, it's a weird one. I wish I could give you a better answer, but at least you see some of the capabilities of this logger and how you can use it, and hopefully in the future I'll get to log some more stuff on this unit.